We've now spent a ton of time perfecting everything inside of our resources directory, and we've done a lot of work on our item model file as well. Now that we've got a ton of infrastructure in here, it's time to actually start focusing on our application itself. So in this section, we're going to start putting together some of the groundwork for the two screens of the application we're going to put together. We're going to end up having the one screen that's going to go show a list of all those top stories, and then we'll show another screen that focuses in on information about one specific story. To get started, I'll flip back over to my code editor. I'm going to open up my root main.dart file, and as you might guess, as usual, we're going to highlight everything inside of here and delete it. So start from scratch. Now inside of here, we're going to immediately do some initial setup of our application. So I'm going to import the package material.dart. I'm then going to assume that we're going to eventually create a file inside of our src directory called app, and that will be the root widget of our application. So I'm going to write an import statement for that right now, even though we've not actually created that file just yet. And then inside of here, I'll define my main function. We'll call run app, and we'll pass in an instance of our app, like so. Okay, so let's now make our root widget. I'm going to make a new file inside the src directory. So inside of src, new file, and we will call this app.dart. And again, just like all the other applications we've worked on so far, this will be kind of this central core or root of our entire application. So at the top, we'll get an import statement for package Flutter material.dart. We'll then build out our class app, which is going to be a stateless widget as usual. Inside of here, we'll define our build method that gets called with some context. And then for right now, we're going to return a material app that is going to have a title of news. I think that works. And then I'll give it a home. And remember, the home right here is the first screen that is going to be showed. So I'll give the home for right now. We'll assume that we're going to call this first screen over here our news list screen. So I'm just going to assume that we're going to eventually have a widget inside of here called news list. And I'll leave it like that for right now. Okay, so quick pause. We'll come back to the next section, and we're going to start working on this news list widget. So I'll see you in just a second. In the last section, we started putting together the absolute root of our application. So we've got our app widget right here, and we're assuming that we're going to have a news list widget to represent this first screen. Now we're going to eventually massage this app widget quite a bit to enable navigation between these two different screens inside of our application. But for right now, just having this single news list will serve us fine, because we're going to have to do a lot of work to get this news list to work the way we expect. So to continue, we're now going to create a new directory inside of our src folder called screens, and inside there, we'll create the news list. So inside of src, I'll make a new folder. I'm going to call it screens, and then inside of screens, I'll make a new file, and we'll call that newslist.dart. And then inside of this new file, we'll immediately put together a little bit of boilerplate. Let's do our import for package Flutter material.dart. We'll then make a class newsList that's going to be extending our stateless widget. We'll put our build method in here that gets called with some context argument. And for right now, we're going to return a scaffold. This will have an app bar. That's going to be an instance of app bar that has a title with some text, and we'll give it the text like top news. I think that works just fine. And then remember, a scaffold also takes a body property, and that will be displayed underneath the app bar. So I'm going to also give this a body, and for right now, we'll give it a text of show some news here, like so. Okay, so that looks pretty reasonable. Now, I see that I still have an error inside of my app.dart file. I'm going to go check that out real quick. So back over here, we are creating our instance of news list, but we never actually imported that file because we hadn't even created it yet. So let's make sure that we add in an import statement at the top of app.dart. So I'll say import screens, newsList.dart. All right, so that looks pretty good. So let's take one more pause right here. During this pause, I would really like it if you open up your terminal inside of your project directory and you started up your emulator and got the app running on the emulator by executing Flutter run. Because in the next section, we're going to start looking at what is appearing on the screen and start actually putting some of this app together. So quick break, make sure you start up Flutter run and get your emulator going, and I'll see you in just a minute. In the last section, we put together some boilerplate inside of our application. Hopefully you had the opportunity to start up your emulator, and so you should now see something like this on the screen of your device. We'll now continue by trying to get some information into our news list widget to actually show on the screen. Yes, we have this repository put together inside of our resources directory, but the repository doesn't really have a good way of serving information that it fetches up to this news list widget. So to communicate information from the repository over to the news list, we're going to be putting together a block widget as we did in the last two applications. So a block widget is going to be responsible for interacting with that repository and then getting some information over to our widget, which will then display it on the screen of our device. Now, please pay attention. One really, really important thing. The block that we're going to make for this application is going to be exceedingly complicated. There's going to be a lot of kind of challenging stuff in it. And it's all going to be driven by two really big concerns that I'm going to tell you right now inside this section. So I'm going to tell you about two really, really big problems that our application is going to face. And then we'll talk about how we're going to solve those two big challenges through the block that we're going to put together. So on the screen right here is a possible design for a block. And I'm going to say bad block. So this is something that we would not want to do, even though it might seem like a very obvious approach to getting information from our repository over to our widget on the screen. So let's imagine that inside of our block, we've got a sink, like a getter, called fetch top stories. And anytime this thing gets called, our block will reach out to the repository. It'll call fetch top IDs. It'll get back that list of IDs, and then the block will then look at every single one of those top IDs and call fetch item on each one. The block will then wait for every single one of those fetch items to complete. And then once it has that big list of all the successfully fetched front page stories, it'll then take that list and provide it to the news list widget right here, which will then render them onto the screen of the device. So this entire flow right here seems like kind of a very obvious flow, and this is absolutely how we would build things if we were making a very simplistic application. But this time around, we've got kind of a little bit more complicated setup for all of our data stuff. And it's all being driven by the complexity of the Hacker News API. Remember, the big challenge behind this API is that it only lets you fetch one individual item at a time. So let's talk about why that's such a big concern. Okay. So quick diagram right here. So this is a flow diagram or kind of a time diagram of how that flow that we just looked at on the last screen right here, like this block right here, would work. So we said using this kind of bad block design, we would call repository.fetch top IDs. And so that's fetch top IDs right here. So this represents that function call. And we're going to imagine that maybe it takes a total of 200 milliseconds for our repository and its underlying API provider to reach out to the Hacker News API, get that list of top IDs, and then return them back over to our application. So once we have that list of top IDs, we're then saying that we're going to look at every top ID, and we're going to call fetch item on every single one. Now think about what that means. If fetch top IDs gives us back a total of 7 IDs to fetch, in reality it's far more than that, but let's imagine it's just 7, that means that we're going to sit around and make 1 request, 2 requests, 3, 4, 5, 6, 7 different requests for each one of those IDs. And as we just said, we're going to wait for every one of those to complete before we take that information and serve it up to our application. So because we have to wait for every single fetch item to complete, we are at the mercy of the longest request. So I'm showing on here maybe the IDs 3 through 7 take only an additional 1 second or 1,000 milliseconds to fetch, and fetch item with an ID of 1 takes a little bit less than that as well. But let's imagine that out of these 7 IDs, one of those requests takes an additional 2 seconds or 2000 milliseconds to complete. That means that we have to wait to render everything on the screen of our device an additional 2 seconds because this one single item right here took a little bit longer to fetch. So that's the downside of this setup right here. If we're going to say that we're going to call fetch item on every single one of those IDs and then wait for every one of them to complete before we take all this information and shuttle it back to our widget, we are at the mercy of the longest request. And so if some request in here fails to complete, or if it just seems to take a little bit longer than all the others, a user is just going to be sitting there waiting for information to appear on the screen of their device, which is obviously super not ideal. Now, that's not the only concern. There's an additional second concern with this kind of block layout right here, with this very bad approach that I'm showing you. And again, this is a bad approach just for this particular app where we have a tremendous amount of information that we're trying to load up. So the second big concern here is around the fetch top IDs function. If you go back over to the Hacker News API documentation, here's the route endpoint for getting those top stories, and the top stories are the top 500 that you and I are trying to show. Notice how the documentation right here says that it's going to return up to 500 IDs. And so right now, if I follow this link, if I open up the top stories, here's a list of all the IDs that we are trying to show on the screen of our device on that first screen. And inside there, really quick, I can tell you that there are 279. So definitely far fewer than up to 500, but the 279 right here can change over time. For example, yesterday I did the same thing and I was getting back 486. So I want you to think about the impact of that for just a second. Clearly, as we just discussed, we're going to be always at the mercy of that longest running request. So if one of those 287 items takes a little bit longer to fetch, and chances are there's going to be one inside there that takes longer, well, then we're going to wait for everything to be completed. Now, the second big issue, and that's what I was kind of getting at, the second big issue around this is I want you to take a look at the mockup that we're trying to put together here. So inside this mockup, we're only showing like 6 individual stories at any given time. So I said over here, like only 10 items visible. Here, let's just say like 6, whatever. But as we just saw, fetch top IDs fetches up to 500 items. And so there is absolutely positively no reason whatsoever for us to attempt to fetch 287 items all at the very start of this application when we're only going to show the user initially about 6 items total. That's total overkill. We do not need to fetch up to 500 items just to show 6 on the screen. So it'd be really nice if we could somehow figure out a way to say, okay, on the screen right now, the user is only trying to look at 6 items. Let's try to just fetch those 6 and do like nothing else. And then as the user starts to scroll around, as they start to, scroll up on the device and go down the list, only at that point in time would we want to attempt to go and fetch some additional items from the API. So that's the 2 big concerns around performance for this application. On the one hand, if we try to fetch everything up front, then we're always going to be at the mercy of the longest running request. And secondly, if we were to try to fetch everything up front anyways, that is a massive overfetch of data. And that's an incredibly large amount of data that we do not need to show on the screen for the user to see the initial list of stories. So at the end of the day, it would be so awesome if we could just fetch like 6 top stories at a time, or whatever the visible stories on the screen of the device are. And in addition to that, even if we're only fetching 6, it would also be really, really nice if we could somehow decouple that fetching process and say that for those 6 stories, we don't have to fetch them all concurrently and then wait for them all to complete. It'd be really nice if we could fetch each of them, and then as each one starts to get a response back, we'll then render that story to the screen of the device. So in this diagram right here, we can imagine that if the 4th item on the screen is resolved like right here, well then right here, let's render that story to the screen of the device. And let's say right here, we'll show item 4 on the screen. And then the instant that we get like a millisecond later, we get 1, 3, and 6. Let's then update the screen again and show the additional 1, 3, and 6, and then repeat the same process when 5, 7, and 2 are completed. All right. So that's it. That's the big concern around performance in this application, and that's why the block that you and I are going to put together is going to be rather complicated solely to encapsulate all these very rigorous demands of our application. Now, of course, if we wanted to, we could completely ignore all this stuff, and we can just say, hey, you know what? Let's just fetch 287 items. Totally could do that, but I can guarantee you that would lead to a pretty poorly performing application, and of course, that's probably not what we want to build. Okay, so now that we have a better idea of some of the big challenges here, let's take a quick pause. We'll come back to the next section and continue working on our app. In the last section, we had a very long discussion about some big problems that we were going to run into as we start to implement our block. In this section, we're going to follow up on those 2 big items we discussed and propose possible solutions to each one. All right, so here we go. Problem number 1. We want to make sure that we show each item on the screen as soon as it has been successfully supplied by our repository. So we're not going to wait for every item to be fetched before we show any content. Instead, as soon as something successfully is fetched, show that item on the screen. And so at any given time, when our page is first loading up, maybe only like a handful of items are actually visible on the screen. And so when we first load up, maybe just these 3 right here are visible, and then the other 3 start to fade in. So individually, we're going to load up every item as fast as we possibly can. To do so, we're going to be returning the future that's going to resolve with an item model from our block. Remember that at present, our repository, so here's our repository code right here, anytime someone calls fetch item, we're going to return a future that will eventually resolve with an item model. And recall that a future in Dart is very similar to a promise in the JavaScript world. So by returning a future from our block rather than the item model itself, we can use something inside of our widgets called a future builder. A future builder is very similar to a stream builder, which we had looked at previously. Remember that with a stream builder, we can supply a build function that will be automatically re-rendered every time the stream emits a new data event. And so a future builder works in a very similar fashion. Anytime a future is resolved with some amount of data, the future builder's build function will be invoked, and that gives us an opportunity to update the content on the screen. We are going to look at an example of a future builder before we actually implement all this block stuff. So we'll be walking into this with at least some amount of good knowledge. Now, the second big challenge we want to make sure that only the items that are visible on the screen should be fetched. So again, if we are only able to see like 6 or 7 items on here, there's no reason to fetch 200 items. We should only be fetching like the first 6 that are actually visible. So to handle that, we're going to again make use of that ListView builder widget. The ListView builder only attempts to render rows that are actually visible on the screen. And so it's going to be essentially up to the ListView builder right here to decide when it is time to go and fetch an additional item model to actually show on the screen. And again, we're going to see a good example of this right away as well. So both these solutions right here involve a pretty good amount of new stuff and new code. So again, rather than just diving into putting together our block and trying to figure this stuff out on the fly, I want to put together a kind of intermediate example, kind of a quick example that's going to give us a better idea of how all this stuff is going to work between the block and our news list widget right here. So let's take a quick pause. We'll come back to the next section, and we're going to put together a little sample bit of code to get a better idea of how a future builder works and how we can use it along with an item builder, or excuse me, a list view builder. So quick pause, and I'll see you in just a second. In this section, we're going to write out a little bit of code inside of our news list widget to get a better understanding of how we're going to address all this data loading issue stuff that we've been talking about. So let's get to it. The first thing I'm going to do is find my scaffold widget right here, and for the body of the scaffold, I'm going to replace the text that we have right there with a new method that we're going to add inside of here that we're going to call build list. So build list is going to be a very temporary little chunk of code. We're going to write out build list just to get a better understanding of how to implement both these solutions. And then after putting this stuff together, we're then going to immediately delete it and start working on the block itself. So we'll define a method down here that's going to return a widget, and it's going to be called build list. So now inside of here, I'm going to first begin by returning a ListView builder. Now recall that the ListView builder has two named arguments that we want to pass to it. The first is an item count. Now for us, we're not going to do any real data fetching here. We're going to use some fake data for this very quick example. So I'm going to pass in just a very arbitrary item count of 1,000. And so we can kind of imagine that this kind of simulates having 1,000 different news items that we want to show on the screen. And of course, we're not going to want to try to simultaneously fetch all 1,000. We want to only fetch a very small subset of that. So in addition to the item count, I'm also going to pass in the item builder, which will be a function that gets called with context, and then the very important second argument of index. So index right here is an integer that reflects the current row that the list view is trying to build. So inside of this item builder function right here is where we are going to build some type of widget that is going to represent one individual line item that is going to be rendered on the screen. So for you and me, inside of this item builder right here is where we're going to want to kind of simulate fetching some data from our repository. And then only when that future that we get back from the repository resolves with our item model, are we going to want to show some representation of that thing on the screen. So inside the item builder, I'm going to return a future builder. And again, this future builder right here works identically to how our stream builder works as well. We're going to pass it a future, which we'll put together in a second, and a builder function that gets called with context and snapshot. Okay, so let's talk about what's going on here. All right, so this diagram right here. So as you well know, when we first try to fetch some data, we get back a future that is marked with a sort of pending status that indicates to you and I as developers, hey, we're currently trying to fetch some given item or the list of top IDs or whatever it might be. And so there's some initial period inside of there where you and I are just waiting for some data to come back from the repository or from the underlying providers that are behind the repository. After some amount of time, the future is then resolved. And so maybe at 2 seconds, the future is resolved with the data that has been fetched from the repository. And that future goes from its pending state to the fulfilled or resolved state. So at this little transition point right here, this builder function will be invoked. So the builder gets invoked with the data that is coming from that promise, or excuse me, from the future on this snapshot argument right here. And so inside of builder, we get the opportunity to attempt to re-render our representation of this very individual line item right here that's being constructed by the item builder on the screen. Now, the only thing we have to do inside of here is make sure that we also provide a future. So in reality, the future that we would want to stick in here would kind of represent the item that we're trying to fetch, like, get item with some particular ID. But like I said, we're just doing some sample code right now. So rather than actually trying to reach out to our real repository or to the block or anything like that, I'm going to make up a fake function called getFuture. And then I'm going to define that function down here. So I'm going to define a function called getFuture. And this is going to return a new future that is going to automatically be resolved after 2 seconds. So it's basically going to kind of emulate this flow right here. We're going to create a future that starts off in the pending state, and then after 2 seconds, it will go to the fulfilled state. So inside of here, I'm going to return future.delayed. I'll pass in as the first argument a duration object of seconds 2. And as a second argument, I'll pass in a function that is going to supply the data that the future is resolved with. So as you might guess, this right here is a future that's going to be automatically resolved after exactly 2 seconds, and it's going to resolve with the data of string high. And so in reality, we might instead, for our real code, we might actually resolve this with an item model if we wanted this to actually represent our real project. Now you'll notice that future is underlined right here, so we do have to import the async library from Dart at the top. So I'll take care of that right now. So up here, I will import Dart async, like so. So now, let me get my comma inside there. That's better. And I'm going to get a second comma around that builder function right there as well. Okay, so we're now providing a future that's going to resolve after 2 seconds to future builder. So now inside of our builder method, we're going to write out some amount of code to show some different text depending upon whether our future has resolved yet. So I'm going to return snapshot.hasData, and I'll make a ternary expression out of this. So if the snapshot has data, which indicates that the future has been successfully resolved, I'm going to show some text on the screen that says, I'm visible, and I'll print out the index of this item. And then for the other case of the ternary, I'll add on text, you can't see me, and I'll print out the index there as well. Now, of course, we will be able to see this text on the screen right here. It is going to be visible. We're kind of saying like, hey, the future has not resolved yet. Anyway, let's just change the text to say that. We'll say, I haven't fetched data yet, like so. Okay, so let's now save this. We'll flip back over to our emulator, do a refresh, and test this thing out. Okay, so you can see I kind of already did a little bit of a refresh there. Okay, so there's the refresh. Now you'll notice that everything starts off saying, I haven't been fetched yet. And then it appears to be that way for exactly 2 seconds. Now, notice how after 2 seconds, all the text automatically flips over to saying, I'm visible, which indicates that our future has successfully resolved after 2 seconds. It reran the builder function right here. And the snapshot now has some data because the feature has been resolved, and the text is updated to I'm visible, and it prints out the index of that particular feature. Now here's what's really interesting. When the list view initially runs and shows some content on the screen, it only renders enough items through the item builder to fill up the screen. And so if we now start to scroll down, the item builder is going to run again for all those additional rows that are now appearing on the screen. When item builder reruns for those additional rows, we will build new features that will resolve after 2 seconds. And so watch what happens when we scroll. I'll go down, and now look how I see that these I'm not fetched yet appears on the screen, and then after a short period of time of 2 seconds, it then flips into the resolve state automatically. Now I can scroll down further, and now the item builder is trying to fetch this data, and we can keep going. And so you start to get the idea here of exactly how we're going to only fetch the data that we need when it starts to appear on the screen. And that's all going to be done through the ListView builder right here. Now, last thing I want to tell you about, because this is kind of an important side case, you'll notice how it looks like the item builder is very, I'm going to do a refresh over here, by the way, really quick. You'll notice how the item builder appears to be very intelligent and only renders like just enough content on the screen to be visible. So it turns out that when the item builder, or the list view right here, initially runs, it renders exactly one item. It sees how tall that is. So like this one item right here, it figures out how tall that item right there is. And then only after it knows how tall that thing is, it then says, okay, item visible at 0 right here is like 10 pixels tall, and I've got like 12 or I don't know, 360 or whatever it is pixels to work with. And so it decides that it can render all the way from 0 to maybe about like 37 right here. However, if our one item right here is any taller, then the range of items that the item builder tries to initially build is significantly constrained. So let's try doing the same thing, but instead of just rendering some text right there, I'm going to wrap all that inside of a container that gets some amount of height. So I'm going to return a container that has a height of 80. And then the child to it is going to be the result of this ternary expression right here. So I'm going to cut the ternary expression, and I will paste it into that child property. I'm going to make sure I get a comma at the end there, and then I'm going to clean up the leftover return statement and semicolon. And then I'll save, and I'll do another refresh. So now that we have a height of 80, the list view is going to render the first item. It's going to say, oh wow, this is actually a tall item. And so maybe I think that as a list view, I'm only going to be able to fit like 7 or so items on here. So now watch what happens when we scroll down. I'm going to scroll down, and then when I get down to item 11 right there, item 11 has not been fetched, where previously we were fetching all the way up to item 36 or 37 or so. So again, the thing to keep in mind here is that the list view is only going to attempt to render the number of items that it thinks that it can fit on the screen. And so that works really, really well for us because it means that exactly as we had said previously, you know what, we're only trying to show like 6 items right here or 10 or whatever it is. So the list view is not going to attempt to try to render and fetch everything down here underneath the list. It's going to just render what it has to right here. So in total, we have now got kind of a working proof of concept that is going to only fetch these top couple items that are going to be visible on the screen. And in addition, it's going to attempt to show each item on the screen the instant that that underlying feature has been resolved. So we're not going to wait for everything to be fetched and then rendered on the screen. We're going to render as soon as we possibly can, and we're going to render the absolute smallest subset as well. Okay, so long section, but hopefully we got a better idea of what's going on here. So last thing I'm going to do, I'm going to clean up all the code that we just wrote because like I said, I just wanted to give you a good practical example of what we were going to do. So I'm going to take out all that stuff and go back to just the news list with the build method. I'll replace build list right here with some text that says show a list. And I'm going to remove the Dart async import at the top as well. Okay, so that's it. Let's take a quick pause right here. We'll come back to the next section and we're going to start implementing our block widget. In this section, we're going to start implementing our block to fetch all of our data inside of our application. Now, in our application, we're going to add a little bit of additional complexity. I know above what we've already seen so far, but we're going to do it for a very good reason. In this application, we're going to put together 2 separate blocks. One block we're going to call the stories block, and that's going to manage this top news listing right here. That's going to fetch all the top news IDs and then show a list of all of them on the screen. In addition, we're going to make a second block that's going to handle showing the story details page, which is supposed to show a summary of the story and all the comments associated with it. The reason that we're going to break this into 2 separate blocks is just so you get a good example of how you can separate logic between blocks inside of a single application if you choose to. We absolutely could use a single block for the entire app, and that's actually how I initially built this application. But just to give you a good example of how this would work with multiple ones, we're going to split it into 2. Now the good news here is that the entire first half of the application is going to be all focused around this list page right here. And so we're going to be able to kind of develop both halves of this application almost in isolation. So even though it's kind of a complicated app, even though it's kind of visually simple in nature, we're going to build like this half first that's going to do the list, and then this half second that's going to show the list of comments. So with that in mind, let's get to it. We're going to start by building our stories block first. So back inside my code editor, I'm going to find my src directory, and inside there, I'm going to make a new folder called blocks. And so as you might imagine, this is going to hold all the code related to both the blocks that we're going to create. I'm going to first create a new file called storiesblock.dart. So that's going to hold the actual block widget itself. And I'll create a second file that's going to be called storiesprovider.dart. So remember, anytime that we make a block, we also make that provider to go along with it, and the provider makes our block available at any location inside of the widget tree. So let's first begin inside of our stories.block file. Inside of here, we'll just put the initial class together. So I'll just say class storiesblock. And then we'll immediately go back over to the stories provider file. We'll import this thing, and then we'll put together the typical boilerplate code that we would expect to see from a block provider widget. So back inside of stories provider, I'm going to first import package Flutter material Dart, and I'll also import the provider that we just created. So stories block.dart. We'll then make a inherited widget called stories provider inside of here. So class stories provider extends inherited widget. Remember, we went over the entire purpose of this provider thing earlier as it pertains to blocks. We make use of an inherited widget, and that allows us to kind of reach up the context at any point inside of our build hierarchy and get an instance of our stories provider, which then gives us access to the underlying block. So on the stories provider, I'm going to add on a final stories block that we'll call block. I'll then put together my stories provider constructor. This is going to take two named arguments. One is going to be a key, and the other is going to be a widget that is a child. We're then going to use the constructor as the opportunity to create a new instance of our stories block and assign it to the block variable right here. So I'll say block is stories block. And then in addition to that, we're also going to call the super of inherited widget, and we're going to pass through the key and the child, like so. And remember, all this code right here we spoke about in great detail back when we first introduced blocks a while ago. Then underneath this, we're going to define that bool update should notify function. This is going to be called with a single argument that we don't care about. So we're going to represent that argument with an underscore. And then we're going to always return true from that method. And then finally, we'll define the static function stories block of. So that's the name of the function right here. This thing is going to be called with a build context that we'll refer to as context. And then from this function, we will return context. And here's that really long function name, context.inherit from widget of exact type. And we're looking for a widget of exactly the type stories provider. Let's collapse this. Then after that method call, we're going to say as stories provider. I'm going to save the file just to get it to reformat. Oh, looks like it doesn't want to, so I'm going to do it for it, like so. And then off of this entire thing, we want to return the .block property, like so. And now it's happy. Now I should be able to save, and I'll see a little bit of formatting kick in. Okay, so again, this is the boilerplate that we're going to see anytime that we make a provider to get our block available at any location inside of our widget hierarchy. I know we went through this code very quickly, but as a reminder, we discussed every line of code inside of here way long ago when we were initially covering blocks before. So now that we've got this together, we'll take a quick break. We'll come back to the next section, and we're going to start with the design of our stories block. So I'll see you in just a minute. In this section, we're going to start working on our stories block right here. Now, before we add any code to the stories block itself, we're going to install the rxstart package, which you'll recall gives us a bunch of helpers to more easily work around with streams and syncs inside of Flutter applications, or really any type of Dart code. So we need to make sure that we install rxstart. To do so, I'm going to open up my pubspec.yaml file, which is inside of my root project directory. And then underneath the other two packages that we've already added inside of here, I'll add on rxdart, and I forget if there's a slash inside there or not. One word, rxdart, like so. And then we want uppercase or caret 0.18.0. I'll then save this file. And then if you're using VS Code, remember you should see the pop-up right here automatically attempt to fetch these new packages. If you don't see this pop up or you're using any other code editor, no problem. You can always go over to the terminal and run flutter packages git, like so. All right, so now that we've got that, I'm going to flip back over to my stories block file. At the top, I will import package rxdart, rxdart.dart, and then we're going to import two other things into this file that I'm 100% positive we're going to need at some point in time. So I'm going to also import our item model from the models directory. So I'll import up one folder, models, item model.dart, and I'll also import from the resources directory, I'm going to grab our repository. So up one directory, resources, repository.dart. Okay, so we now got everything that we need inside of here. Of course, it has been quite a bit of time since we've worked with blocks at all, so I just want to do a very quick review on what we do inside these. Okay, so here's our block right here. Inside of a block, we usually create a stream controller. A stream controller gives us both a sink and a stream. The sink gives us the ability to kind of put some information into the stream. So we cannot add information to the stream directly. We have to go through the sink. We usually make the sink right here accessible through a getter on our class or our block right here. So that kind of exposes the sink to the outside world. So then anytime we call that sync, we get the function back, which allows us to add in some information that will be sort of redirected over to our stream. Then our stream is going to do some amount of processing and make all the information coming out of it available to the outside world, where it can be consumed by widgets inside of our application, or more specifically by those stream builder widgets. Now, the other quick reminder I want to give you, we're making use of RxStart. So in the RxStart world, we have these different pieces of terminology than what Dart uses by itself. So anytime in the Dart world we refer to a stream controller, that's the same thing, more or less, as a subject in the RxStart world. And then in the Dart world, we refer to streams. In the RxStart world, they refer to those as observables, which again are very similar, but have a bunch of additional functionality on top. Okay, so just quick review. So now that we remember all that, we're going to flip back over here and we're going to create our first stream controller, which is not going to be quite a stream controller. We're going to make a subject instead. This first subject is going to have the purpose of fetching and making all the top IDs available to widgets inside of our application. So I'm going to create a variable that I'll call top IDs. Notice that I'm using an underscore right here on the variable name, which means that this is a private variable that cannot be accessed outside of this file. Then I'm going to assign to this a new instance of a publish subject. Again, remember that a publish subject is very similar to a normal stream controller in the Dart world. It has a little bit of additional functionality tacked onto it, and we'll talk about what that is at a future point in time. Then I'm also going to annotate the type of data that is going to be flowing through this stream controller. Because this is going to work with a list of top IDs, I will annotate its type as list of integers, like so. So essentially, we now have our stream controller in place. That gives us our sync, it gives us our stream. So if we now get access to our repository and attempt to fetch that list of top IDs, we can take that list of top IDs, dump them into the sync, and then the stream controller will automatically direct that list of integers out to be consumed by different widgets inside of our application. But we still have to do a couple of steps to actually make that happen. So the next thing we'll do inside of here is we'll define one of the getters to get streams. So this is where we actually kind of implement this side right here, where we get access to a direct stream that can be used inside of our application. So I'm going to declare a new getter by using the get keyword, and I'll call the getter top IDs. I'm also going to annotate the type of value that gets returned from this getter. It's going to be an observable, if I can spell it. Remember, an observable is very similar to a stream, and that's kind of one of the two things that gets created when we make this publish subject right here. So the observable is going to have a list of integers flowing through it. So anytime someone calls this getter, I'm going to return top IDs.stream. Okay, I'm going to save the file. One quick thing I want to mention here, if you hover over top IDs, you'll notice it says close instances of Dart core.sync. So we are creating a new publish subject right here, and Dart wants to make sure that we do some cleanup at some point in time. So at the very bottom of the file, or the bottom of this class, I'm going to add on a method that I will call dispose. And inside of dispose, we will do some cleanup. If anyone ever calls dispose, we're going to call all the different stream controllers that we've created inside of here. So inside of here, I'll call top IDs.close, and that will make that warning message go away. All right, so this looks pretty good. Let's take a brief pause, come back to the next section, and we'll continue working on our stories block. In the last section, we started working on our stories block. So we set up the publish subject that you'll recall is a stream controller, and we also set up a getter that gives access to the stream on that stream controller. We now need to make sure that we have some ability to get some information into that stream controller in the first place, which we do through the use of that sync. Now, the sync that we set up in this application is going to be a little bit different than what we did on the previous one around that login form. So before, the source of information, the place that we wanted to add information into our sync from was our widget, right? We had some input widget. Anytime a user typed in that thing, We took that new input text and we shoved it into the sync. And so to facilitate that, inside of our block, we had set up a getter that returned like, top IDs.sync.add or whatever it was. However, this application, little bit different in nature. This time around, the source of information to our stream that is going to maintain this list of top IDs is not the widget. Instead, the source of information is the repository. It's the repository's job to fetch those top IDs and return them to the block. So because of that, we are not going to make the sync publicly available. There's going to be no widget that is going to directly access the sync and try to add information in, because no widget knows what those top IDs are. It's only the repository that does. So rather than making a getter inside of here that will return that sync, we're going to instead create a function. We'll call it fetch top IDs. And then anytime a widget, so a widget will call this thing, anytime a widget calls this function, we'll get our list of top IDs from our repository, and then we'll add it into our sync on the top IDs stream controller. So let's write out the code for that. Very straightforward in nature. All we have to do is get the list of top IDs. So I will await repository. Oh, you know what? We neglected to make a new repository. That was my mistake. Let's make sure that we very quickly make a repository. So we'll do final repository. It's going to be an instance of a repository. So now we can await repository.fetch top IDs. Notice how await is underlined with red right here. So I'm going to add in my async keyword. And then after we get that list of top IDs, we'll then add it into the sync on top IDs published subject. So top IDs.sync.add, and we'll toss in that list of IDs like so. Cool. All right, so we now have the ability to get information from the repository, add it into our stream controller, and so that information is available to the outside world through the use of this top IDs getter right here. So we now have enough code inside of our stories block to put together an initial implementation of our news list screen, or at least some initial implementation that will show a list of item IDs on the screen that we can scroll through. So let's take a brief pause. We'll come back to the next section. We're going to wire up the stories block to our application, and then we'll make use of it inside of the news list widget. In the last section, we put together an initial implementation of the stories block. So this thing is definitely not completed yet. Right now, it only gets a list of top IDs. It does not actually fetch any stories. But that's enough code to actually test it out inside of our news list screen. The first thing we're going to have to do is create a new instance of our stories provider. So that's the provider for the block, and wire it up to our application. Let's do that inside of our app.dart file for now. So I'm going to open up app.dart. Here's where we create that news list. And so let's say that rather than just returning the material app, I'm going to first attempt to create an instance of the stories provider, and that's going to wrap the material app. And so the stories provider will be available to the entire application. So at the top, I'm going to import blocks stories provider.dart. And then inside the build method, I will return stories provider. Remember, this thing takes a single child that will be actually displayed on the screen. And so that's going to be the material app right here. So I'll cut the material app out and paste it in as the child. Don't forget to get a comma on the closing paren of the stories provider, and then we'll clean up the return statement. Okay, so that looks good. Now, anytime our app starts up, it's going to create a new instance of the stories provider, which in turn will create a new instance of our stories block and make it available to every widget inside of our application. Okay, so we're all done with the app.dart file, so I'm going to delete that. And then I will open up the newslist.dart file. Inside of newsList, we're going to need to get access to that stories provider again so that we can call that of function on it right here. Remember, this of function is how we get access to our block at any location inside the widget hierarchy. So to get access to that thing, I'll open up the stories block file, and then I'm going to import up one directory, Oh wait, I'm in the wrong file. I apologize. Not the stories block file. We want the news list file right here in news list. So news list, we want to import the stories provider. So we'll import up one directory, blocks, stories provider.dart. Then inside the build method, we'll get access to our block. We'll make a new variable called final block, and this will be stories provider dot of, and we'll pass in the context. So remember, context right here is the magic little thing that gives us essentially a reference up our hierarchy or up the widget tree, and we're going to crawl up the tree until we find an instance of the stories provider, and then that returns the reference to the block tied to the stories provider. So now inside of news list, we can get access to the stream tied to this thing and attempt to actually fetch some data. Let's take a quick pause right here, and then we'll continue in the next section and start wiring the block up to this. In the last section, we wired up our stories provider to our news list widget, so we now have access to our block. We're now going to use this block to render our list of top IDs out on the screen. So we're going to do all this logic for rendering out the top list of IDs inside of a helper method that we'll put together inside of here. So I'm going to replace text right here with a new method that I will call build list, and then into it I will pass my block. I'll then define that helper method on here. So I'll do widget build list, which will be called with a stories block. Now, one thing you'll notice here is that stories block is underlined as an error. It says that it's an undefined class. So that actually makes sense. At this point, we've only imported the stories provider. So the stories provider, the only thing that this thing exports is the idea of the stories provider type right here, stories provider. So if we wanted to access the stories block type inside of the news list file, we would have to also import the stories block file inside of here as well. Now, when you think about it, it kind of feels a little bit silly to have to always import both the stories provider and the stories block file in here just to get access to that type. So one way to kind of get around all these very repetitive import statements would be to add an export statement to stories provider as well. So inside of stories provider, in addition to importing stories block, I'm also going to export it at the same time as well. So now anyone who imports the stories provider file is going to get access to both the stories provider type, or this class, in addition to the stories block class as well. And so now if I go back over to my news list, you'll see that this file is now very much aware of what the stories block type is. Okay, so that's a good improvement. So now inside of here, we're going to return a stream builder that is going to look at the stream on our block that is supplying that list of top IDs. So I'll say stream block, and then the stream that we care about is on that top IDs getter. So top IDs, like so. Then on the stream builder, we're going to also add on our builder function that gets called with context and that snapshot thing. Now, one quick item that I want to remind you about, right now we're building out this build list method, which looks very similar to that code that we put together a little bit ago, where we kind of took a look at that future builder. Just to be really clear, that entire process was all about showing the actual individual items on the screen, right? That was kind of the solution for how we're going to show individual fully fetched item models. Right now, we are not working with item models. We are working with a list of integers that represent the top IDs coming from the API. So the code is looking very similar, but at present we are rendering a totally different thing on the screen. We're not rendering the actual item models. We're just kind of doing an intermediate step here of making sure that we can get the top IDs to appear. So now inside of our builder, we're going to say if the snapshot has data, and we'll say if this thing does not have data, so we've not received any data over the stream yet because the list of top IDs has not been fetched, then we'll just return some text that says still waiting on IDs. Otherwise, we will return, how about a ListView builder? We'll give this thing the item count of snapshot.data. And remember, snapshot.data represents the actual fetch list of IDs that we've gotten back from the API. And so we're going to provide the length of that. So the total items or the total number of IDs that we've gotten. Oh, and I misspelled length. There we go. And then we'll do our item builder as well. So this will be context and the integer index. And then so inside of here, we'll just return a text node. And inside that text node, we're going to look at this list of IDs that is contained inside of snapshot.data. So snapshot.data, and I want to print out some particular ID, or the ID at the given index, like so. All right, so again, just a quick reminder, this code looks very similar to what we did just a minute ago to demonstrate the use of that future builder and those futures and whatnot. This is not quite related to that. This is just some very temporary code that we're putting together just to make sure that we can get our list of top IDs to show up on the screen. So let's test this out. I think that we're almost there. There actually is a very subtle bug that we have right now, but hey, let's just refresh this thing and see what happens anyways. So I'll do my refresh. And there we go. And you'll notice that it says still waiting on IDs. And you're going to find that it never actually resolves to showing any IDs. So at present, we are missing one very important step. At no point in time, inside of all the code that we've written so far, have we ever attempted to call that fetch top IDs function in the stories block. So we've wired up everything to listen to the top ID stream, but at no point in time did we actually reach out to the repository, get the list of IDs, and then add them to the sink. So inside of newsList, inside my build method, right after we fetch that block, I'm going to call fetch top IDs. Now, one important thing, I'm going to put a comment right here that says, this is bad. Don't do this. Temporary. So why is this bad? Well, we got a build method right here. And remember, the build method inside of any given application can be called many, many, many times. So right now, anytime the build method is called, we're going to initiate a request off to some API that is then going to eventually initiate some change or re-render of our application. Now, in this very particular case, that is okay because the part of the application that gets re-rendered is a child to the news list. In other words, it is this stream builder widget right here that's going to re-render. But if fetching the top IDs caused our news list itself to re-render or to rebuild, then we would immediately go into an infinite loop where we just constantly attempt to fetch the top IDs again and again and again. Every time we get the list of top IDs, build gets called again, and we call fetch top IDs to fetch them again. And that process just repeats over and over. But for right now, this is okay for a very temporary testing step. All right, so I'm going to save this file, and then we'll do a refresh, and we'll see how we're doing. All right, so you'll notice we got an error message over here, which is totally fine. So this is the error I was talking about. So let's take a quick pause right here. We're going to come back to the next section, and we'll talk about exactly why we're seeing this thing. In the last section, we tried to test out our code, but we immediately got an error message on the screen. So if I scroll up to the very top here, you'll see that we get our printed out error message. It says type int is not a subtype of type string. So this is a very subtle thing that I just wanted you to see on your own, because at this point, you'll notice that inside of all the code we've put together, we haven't done a very good job of annotating the different types of data flowing around. For example, on the builder function right here, we're getting this snapshot. If you hover over snapshot, well, it says that it's an async snapshot that contains a dynamic value. But that's not what really is coming across our top IDs getter right here. Whenever the stream right here of top IDs emits a new data event, that's going to be contained inside the snapshot. And so the snapshot is going to contain a list of integers. And so one thing that we could have done to kind of add a little bit more information to our code here and give Dart a better idea of what's going on, we could have annotated the type of snapshot. So I could have said, hey, Dart, just so you know, I expect this to be an async snapshot that's going to contain a list of integers, like so. And now the instant that I add on that little bit of information, you'll see that I get an error appearing down here. And so if I hover over this, you'll see that the error message that I see is very similar to what we just saw in the terminal. So argument type int can't be assigned to parameter string. So what this is saying is right now we're trying to show an integer inside this text node. The text node does not expect to be called with an integer, it expects to always receive a string. So to solve the error, all we have to do is a little bit of string interpolation. So I can use a little shortcut here, I can put down a quote, $, and then wrap the entire thing with a set of curly braces like so, and then close off the quote on the other side. And now that error message goes away. So this is kind of a repetitive problem or a repetitive issue that we've seen throughout Dart. Yes, you can ignore the type annotations, but if you go through the time of adding these on, very frequently they're actually going to save you a little bit of pain. All right, let's try doing a refresh now that we've fixed that error up. So I'll do my refresh. So we see still waiting on IDs, and then that resolves eventually with the list of all the top IDs that have been fetched from our API. And so I can now scroll through this list and see all those different IDs appear on the screen. Cool. Well, I know this app has been a long time coming. We've written a lot of code without seeing anything meaningful on the screen, but it looks like we're finally getting a little bit of progress. Now, this definitely works, but kind of unrelated to all this data fetching stuff, one thing I want to point out is that when we're waiting on that initial fetch, just showing that text on the screen of still waiting on IDs or whatever the text was, like let's do the reload. Yeah, there we go. Seeing that text, kind of boring. A user probably doesn't want to see that. So let's take a quick break. We'll come back to the next section and we'll figure out how we can show a little bit more meaningful kind of progress weighty thing to the user than that very boring text. So quick break and I'll see you in just a minute. Our application is now working out pretty well, but whenever we are waiting on that initial data fetch of those top IDs to finish up, we just see that very plain text of still waiting on IDs. Definitely not ideal. So to get a little bit better kind of waiting or loading experience in place for our users, we're going to use a built-in widget inside the Flutter library. So very quickly, we'll look at some documentation. So I'm again at flutter.io/docs, or you can go directly to docs.flutter.io. And we're going to do a search for circular progress indicator. And so it's going to be this circular progress indicator class right here. All right, so this is a very simple widget that just shows a kind of spinner on the screen. And we can use it anytime that we want to indicate to our users that we are doing some amount of data loading. So to show the circular progress indicator on the screen, well, really straightforward, very simple. You can take a look at the constructor right here. Not a terrible lot of customization to it. All we really have to do is create a new instance of it and return it from our builder function rather than the current text that we're showing right here. So inside of the builder, inside of where we check to see if the snapshot has any data yet, I will remove that text and I will replace it with circular progress indicator. And we'll do a save and we'll test it out right away. So I'll do a refresh at my terminal and let's see how that looks. Okay, so here we go, and you'll notice, all right, well, very briefly I saw the indicator up at the top left, but the issue was that it was at the top left of the screen. And chances are we're going to want it to be nice and centered in the very middle. So to center an element, we've gone over this before, we can return a center widget, which takes some child and attempts to center it entirely on the screen with all the space that is available. So to the center widget right here, I'm going to pass that entire circular progress indicator. I'll make sure that I get a comma at the end, and then I will clean up the old return statement like so. Okay, so I'm going to save this again. We'll do another refresh. And now we see that nice indicator at the very center of the screen. Now on my screen on this recording, that animation looks a little bit blocky or a little bit chunky. That's just because of all the software I'm running. Again, my laptop, although it's fairly modern, I'm still running a lot of stuff right now, so that's why it looks a little bit chunky. If I ran this on an actual physical device, that little spinner would look quite smooth. And hopefully on your own emulator, if you have a reasonably modern machine, it would look pretty smooth as well. Okay, so that's a great way of indicating progress to our users and letting them know that we are fetching some amount of data. So let's take another break. We'll come back to the next section, and we're going to start to move forward and make sure that we fetch the actual item models that are associated with each of these item IDs. So quick pause, and I'll see you in just a minute. Our news list widget is in a pretty good spot, but at present it's only showing a list of all the top IDs on the screen. And we don't really care about showing the user the top IDs, we want to show them the actual stories that correspond to each of those IDs. So between our news list and our stories block, we need to figure out how we can take those IDs and turn them into an actual story that can be shown on the screen. Now the challenge in here, the big complication, is that we don't want to just take all the top IDs that come through this stream controller inside of stories block and instantly fetch each one. Remember, we only want to fetch the IDs of the records that are currently being displayed on the screen. And so back inside the news list widget right here, if we scroll back down to the build list method, it is this list view right here that is deciding what is currently visible on the screen. So only when this thing says, oh, hey, I'm trying to show like the element with ID or the story with ID blah, so-and-so right here, only at that exact point in time do we want to attempt to fetch that individual story from our repository. That's the big challenge. So in this section, we're going to look at a rather complicated diagram that's going to lay out the full story and give you a good idea of how we're going to say, okay, whenever this item builder decides to show some given ID, let's go back over to our block and attempt to fetch that very particular and that very singular item. All right, so here's the diagram. Kind of crazy, I know, but we'll walk through it step by step. So up at the top, we've got our news list, right? That's the widget, nothing crazy. The news list shows a stream builder that is connected to the top IDs stream controller. So anytime we fetch a new list of top IDs, the stream builder is going to rebuild, and that's going to show a new list view. Now, in reality, we're generally only going to be fetching a new list of top IDs at very specific intervals at very specific times. So in general, we can kind of imagine that this stream builder right here is kind of static in nature. So inside that stream builder, we have our list view. So it's this list view right here that has a ton of control over our application. So we can imagine that at some point in time, this list view is going to say, oh, it looks like I need to show IDs 1, 2, and 3 on the screen. And so before list view right here can really truly show those on the screen, it needs to fetch the item models corresponding to each one. So we're going to make sure that when our list view decides to show items 1, 2, and 3, it's going to reach out to a new stream controller that you and I are going to put together. So this stream controller is going to have a sink. So this sink right here is going to receive information from a widget inside of our application. So unlike the top ID stream controller, where we really only exposed the stream on it, the item stream controller is going to have the sink and the stream both exposed. So as soon as list view decides to show items 1, 2, and 3, it's going to add those 3 IDs to the sink over here. Our item stream controller will then take those 3 IDs, one at a time, and fetch each one of those IDs from our repository. So on the repository, it'll call fetch item with ID 1, it'll call fetch item with ID 2, and it'll call fetch item with ID 3. It will then attempt to fetch each of those, and then it will stick each of those items into the output stream. So this stream right here is going to contain a bunch of different item models that we are in the process of trying to fetch. Okay, so let's go back over to list view now. So on the list view is going to want to show a widget or just some child inside of it for every item that we're trying to fetch or every news story. So if the list view right here is trying to show items 1, 2, and 3, it's going to say, hey, go fetch 1, 2, and 3, and simultaneously it's going to render a widget that is supposed to show item 1. It's going to render a widget that's supposed to show item 2, and it's going to render a widget that's supposed to show item 3. And so each of these 3 things right here needs to know about when this stream has produced the item model that it actually cares about. So we're going to hook up this stream to a stream builder that exists inside of each of these children. So now all three of these widgets right here knows when the item stream controller has fetched some new item that is now ready to be displayed on the screen, or at least soon will be ready. However, one quick thing I want to mention. Remember that we want to show each item the instant it has been fetched, and we want to show it independent of any other item inside of our application. So inside of each of these widgets right here, we're not only going to have a stream builder that watches the stream for changes, but we're also going to have a future builder as well. So this stream right here in reality is not going to be emitting just item models. It's actually going to be emitting futures that resolve with an item model. Let me drag that down. I don't know how to best reflect this on here, but you kind of get the idea. The stream is going to be returning futures that resolve with an item model. And so every individual one of these items right here is going to know about the exact status of its item model being fetched. So every single item is going to see anytime some new activity on the stream controller has occurred. It's then going to receive this future that resolves with the item model. And so we'll hook that up to a future builder. And so every single one of these widgets knows exactly what's happening. It knows when the item model is about to be fetched. It knows when it's in the process of being fetched, and it knows when it has been fetched. And so we can actually change our UI based on every one of those states and make it really clear to the user, like, hey, this current story right here, we're still in the process of fetching it, but this one is all done, and this one hasn't even started yet. So we can really, really customize our UI based on our data loading state. Okay, so that is kind of the top level view of what's going on here. So it's very clear that we need this item stream controller that is going to take in some IDs and then try to fetch each of those and then pump out a future that will resolve with an item model. And then we'll make that available to each one of these child widgets. However, one gotcha. So there's one little gotcha inside of here. It's a nasty gotcha, but it's a gotcha nonetheless. And it's going to kind of affect exactly how we put this stream together. And I want you to understand what this gotcha is right now, rather than us start to write out some code and say, oh, wait, something's wrong here. So let's take a quick pause. We're going to come back to the next section, and we'll talk about what the gotcha is in all the stuff that we just described. So quick break, and I'll see you in just a minute. In the last section, we laid out an overall architecture for how we're going to eventually get all of our items to display on the screen. Now, one quick thing I want to mention here, all the complexity that you see here is not necessarily normal for a Flutter application. We are seeing all this complexity because we wanted to put together an application that absolutely 100% optimized all this data fetching stuff. We could have very easily put together a far more straightforward application if we did not care about performance at all, and we were okay with just attempting to fetch like 500 items at a time and show them all on the screen simultaneously. If we wanted to go with that route, dramatically less code than what we have right here. So what you see is what we have to do to really optimize the entire process. Okay, so with that disclaimer out of the way, in the last section, at the very end, I had said that everything I described, yeah, it's pretty much right, but there is one little gotcha inside of here. And so the one little gotcha revolves around how this stream right here works. So this is the item stream controller that's going to eventually get some information over to each of these widgets, and each of these widgets is supposed to represent a very particular item. Okay, so I'm going to change over to another diagram here. And same one more or less, but I'm going to delete a couple items on here just to make this all a little bit easier to understand. So I'm going to take off a couple arrows, move the labels around, and I'll take off that, and I'll take off, how about this entire thing? Like so, and we'll leave it with just the stream. And then I'll clean all this up too. Okay, so that's better. So in the last section, I had said that the items controller right here was going to be emitting these futures that are going to eventually resolve with an item model. And as we had said, we wanted to, above all else, make sure that every one of these item models right here, or every one of these kind of data events, is emitted from the stream as soon as possible, so that each one of these widgets can show its respective item model as soon as it possibly could. Now there's just one little problem with that description. I want you to remember how a stream works, and more importantly, how a stream builder works. So we've said several times now that when we have a stream is going to emit a series of events, right? It's going to emit a series of data events. So we can kind of imagine that we might have, like, here's event number 1. It's a feature that's going to resolve with an item model. And then right after it, like a half second later, is going to be another event that's going to be emitted, like so. And so we kind of got this like series over time of events that are being emitted from our stream. Now here's the catch, here's the gotcha. Our stream builder right here, and right here are watching this stream, and it's watching for every data event that comes out of the stream. When a data event is emitted, this stream builder right here calls its builder function with absolutely only that latest, most brand new event. So what does that really mean? Let's imagine that we've got like, let me take these arrows off really quick. Let's imagine that we've got these 3 item models that we really care about. And I'll put on here item model 1, 2, and 3. And as you might imagine, we want this one to go to ID 1 right here. We want this one to go to 2 and 3 to go to 3 over here. So maybe at some point in time, the ListView that was a parent to all this stuff says, oh yeah, go fetch 1, 2, and 3. Item stream controller starts doing that fetching work. And then eventually it says, okay, I've like done the requests. I've got everything lined up. Time to emit this stuff. So here's what happens. The stream is going to emit item number 1 right here. Stream builder, stream builder, stream builder all look at that stream and say, oh, fantastic. It just emitted a new thing. I'm going to take whatever that new thing is, and I'm going to check to see if it is the item that I care about. If it's the item that I care about, I will then show that item on the screen. And so think about what happens here. This item goes to the stream builder, and in this case, stream builder says, oh, it's item number 1. Well, I'm looking for ID number 1. Fantastic. I'm going to rebuild myself and show this thing on the screen. That's great, but at the same time, that same data event goes over to the second widget as well. Now in this case, stream builder looks at this item and says, oh, you're item number 1. Well, I'm looking for number 2. Sorry, but I don't really care about you. And so this stream builder is going to stay in some type of like loading state, and it's going to show a spinner on the screen or something similar. And then that same event is going to go over to 3, and a very similar thing is going to happen. This one's going to say, oh, okay, like, sorry, I don't care about you. I'm going to continue to show a loader. And so at this point in time, it kind of seems like everything is fine and good. Item model number 1 went to the correct widget. It's showing on the screen, but the other 2 are not showing anything yet. They're still kind of in a pending state. Now here's where things get crazy, okay? After some amount of time, our stream is going to emit item number 2. Stream builder, stream builder, stream builder, all 3 of them see this new data event. The new data event is going to be passed to all 3 streams, and there's no way that you and I can change that. And so item number 2 right here is going to go to stream builder number 2. And here's what happens inside of this stream builder right here. This one is looking for ID 1, and it's already gotten it. It's already seen this item number 1 right here. But remember, these widgets that we are working with are stateless widgets. And so this widget right here, it does not know that it already found the data event that it cares about. It doesn't know. It has absolutely no ability to remember the fact that it already got the thing that it cares about. So this stream builder receives item number 2 right here. And it says, oh, you know what? I'm so stupid. I don't even know that I got item model number 1. Hey, here's item model number 2. Well, you know what? I don't care about item model number 2. So I'm going to just go back to my normal loading state because I have not gotten the data event that I care about yet. So that is the big issue. Every time this stream right here emits a new data event, every one of these stream builders rebuilds with exclusively only that new data event. And because these are stateless widgets, they do not have the ability to say, oh, well, I already got the thing I care about. It's going to rebuild with the new data event And even if it already got the thing it cares about, it has no ability to remember that. And so this widget right here is going to reset back to its initial state. So in short, at any given time, only one of these widgets right here will be showing the correct thing on the screen. Think about it. The first event that comes out is number 1. And so this one says, oh, fantastic, here's my data. And so the other two are kind of blank. Then maybe item number 3 comes out. Item 3 comes out, it goes to this stream builder. This one says, great, I've got something to show on the screen now. But that also goes to this one, and it also goes to this one. And so both of these widgets right here say, oh, this is item number 3. I don't care about that. I'm going to revert back to my blank state and show just like a spinner on the screen. Well, 3 shows the correct thing, but now 1 and 2 are showing the wrong thing. And so then finally 2 comes out, 2 goes to all 3. And as you might imagine, now 2 shows the correct state, but now 3 shows the wrong thing and 1 shows the wrong thing. All right, so that's it. That's the big gotcha. And this is something that will haunt you. It's going to haunt you when you start using this block stuff in your own application. The stream builder is watching for every single event, and it's going to rebuild itself for every single event, and you have no ability to stop that. Well, clearly there's got to be a workaround here, right? I didn't just lead us down this path for no reason. So yes, there is a workaround, and it's not the worst thing in the world. So as you might guess, let's take a break. We're going to come back to the next section, and we're going to talk about how we're going to fix up this entire problem.